Okay, today we're going to look at a second factoring pattern called the difference of two squares. And it's a very common pattern that you'll need to know. Okay, here's how it works. A squared minus B squared is equal to A plus B times A minus B. And again, there's a reason for that that's pretty simple. But with this video, I just want to show you how to do it to remind you of that. So we're just going to look at several examples using this pattern. Okay, so I'm going to start with a simple one, x squared minus 49, and our instructions here are going to be to factor. Okay. Now in this case, if you're looking at this example, a squared minus b squared, I'll show little notes on this one that ordinarily people don't show. A squared is like your x squared, and b squared is like your 49. Okay. If you're trying to show this and lining it up with this. So a squared is x squared, b squared is 49. Well, over here, we need not a squared or b squared, we need a and b. Okay, so what would a be if a squared were x squared? Well, it doesn't take long to figure out if a squared is x squared, then a would be x. That is, you just take the square root of x squared. If b squared is 49, then b would be 7. Okay, because 7 times 7 is 49. The square root of 49 is 7. So what I'm going to do then is take this a and b and just plug it into this pattern. Okay, so the first one's a plus b. That would be x plus 7. The second one's a minus b, which would be x minus 7. And it's as simple as that. And come to find out, it wouldn't matter. If you were to put the negative first, that would not matter. You could say x minus 7 times x plus 7. Now, people usually don't do this. The way they think about it is they think about, all right, this is a perfect square minus a perfect square. Therefore, I can factor it. To factor it, I take each square root, I add the square roots, and I multiply that times the difference, or subtracting the two square roots. Okay, so another example, x squared minus 121. Well, again, we'll do it without going through this time. What's the square root of x squared? That's x. What's the square root of 121? That's 11. Doesn't really matter how you fill the gaps as long as one's a plus, one's a minus. I'll just stay pretty consistent with putting the plus first, though it doesn't matter. Okay, making this one a little harder. What about 4? We'll just throw a different letter in there. A squared minus 9. The a doesn't, it means nothing. It's just a different variable. Slightly harder. Now, what times itself makes 4a squared? Well, that would be 2a. All right, because 2 times 2 is 4, and 3 times 3 is 9. Excuse me. A times a is a squared. I got ahead of myself a little bit. 2a times 2a is 4a squared. Now, what was said just a minute ago, I didn't mean to. What times itself makes 9? That would be 3. Okay. And again, fill your gaps with a plus and a minus. Sometimes you see a case where you can do it again. Let me first show you this. If you had something like x squared plus 25, be careful. That does not factor the same way. It actually does, but you have to know imaginary numbers, which for this video, for the class that's using this video, we don't know that yet. So if there's a plus here, though it looks almost identical, you can't do it, at least not yet. Okay, so we would say this is prime. Prime means it won't factor. Okay, you will sometimes see one of these where you are, let's say x to the 4th minus 16. Something like this is pretty common. Now, x to the 4th, that is a higher power. And I don't know that you don't have to worry about this quite yet, but it's still a good extension. Most of what we're working with in this chapter would be quadratics, highest power 2. But it's a bit of a challenge here. What times itself makes x to the 4th? You have to know your exponent rules a little bit, but that would be x to the 2nd. x squared times x squared is x to the 4th. And of course, there's a separate video for exponent rules. What times itself makes 16? Well, that would be 4. It's pretty easy. Make 1 a plus, 1 a minus. Okay. Now, looking at number 4, we know that this is done. Okay, and here though, x squared minus 4, you can apply the same pattern again. That is, I can factor this into two different things. What times itself makes x squared? That would, again, would be x and x. What times itself makes 4? Would be 2, wouldn't it? And notice that the power here is x squared. The power on each of these is x to the 1st. But this would be the complete factor. And sometimes you'll see the instructions that says factor completely. That adverb completely implies that sometimes you can apply a factoring pattern more than once. Okay, that's the difference of two squares.